In this video, we'll explain how to use PWM, pulse width modulation, with an Arduino to control the brightness of an LED and the speed of a DC motor. We'll use pin 3 to control the LED, and pin 9 to control the motor through a transistor. We will also connect an oscilloscope to both pins to visualize the PWM waveforms. What is PWM? PWM stands for pulse width modulation. It allows us to simulate analog voltages using digital signals by sending very fast on and off pulses. A high pulse for a longer time equals higher average voltage. A short high pulse equals lower average voltage. This technique is useful for dimming LEDs, controlling motor speed, or even generating sound. Let's begin the explanation of the code. The first variable is called LED pin, and we assign it the number 3. This is where the LED is connected. The second variable is motor pin, set to pin 9, which will control the motor using a transistor. In the setup section, we tell the Arduino to use pin 3 as an output for the LED. We also set pin 9 as an output for the motor control. Now both pins are ready to send PWM signals. In the main loop, we create a simple PWM fading effect. We start a loop that counts from 0 to 255 in steps of 55. So the values go 0, 55, 110, 165, 220, 255. Each value represents the duty cycle of the PWM signal. At each step of the loop, we send the current value to pin 3 using analogWrite to adjust the LED brightness. We send the same value to pin 9, so the motor speed increases with the LED brightness. Then, we wait 500 milliseconds before moving to the next level. After the fade is complete, we pause the program for 3 seconds. This gives time to observe the result before the loop repeats. White heavy checkmark summary. We used analogWrite to control brightness and speed. We used PWM pins 3 and 9. We made values go up in steps of 55, with half-second delays. We added a 3-second pause at the end of the loop. We can visualize the PWM waveform using an oscilloscope.